Hi everyone, welcome back. We are now going to look at finding the vertex form of a quadratic function from the general form of a function. So I've got a very simple quadratic function here. We're going to put it into vertex form, and the idea is we're going to complete the square. So if you know how to complete the square, this is not a hard problem at all. So if you take f of x, the first thing we want to do is instead of moving the constant to the other side, we're just going to group the x squared and the x term together, and I'm just going to leave myself a little space plus 5. And we're going to do the same thing as we did before. We're going to take this negative 4, do some side work. Let me draw my arrow a little more nicely. There we go. So negative 4 for some side work. Divide by 2, we get negative 2. This is what we're going to save. Then we're going to take the negative 2 and square it and get a 4. So that plus 4 is going to go in here. But we said that if we add 4 to one side, we have to add 4 to the other. So you may think this is what we will do. And this is technically not wrong. So let's get rid of some of those red arrows here. So this is technically not wrong. I added 4 here and I add 4 here. But we almost rarely never write that. This is what we write instead. We would write x squared minus 4x plus 4, and we would write plus 5 minus 4. So notice that when we're dealing with completing the square on an expression, we usually just add 4 and minus 4, because that's plus 4 minus 4 is 0, and you don't change anything. But if it helps you to add to 4 to the other side and then move it over by subtracting 4 from both sides, that's perfectly fine. I have no problems with that. So then we have f of x equals x minus 2 all squared plus 1. And here we are in vertex form. So there we go. There's an example. There are more complicated examples out there, but I think with this little model you can figure those ones out. So I will see you in the next video.